Okay, it's about time to get started. It's 11 o'clock. I want to thank everybody for taking the time to come here and listen to what we have to say about file server technologies. My name is Brian Dewey. I'm a program manager in the core file server division. And actually, I'd like to get started with a simple show of hands. How many people are here because they want to know about all the cool technology related to file servers that will be coming in .NET Server? Excellent, excellent. How many people are here, and you can be honest, how many people are here because you're a little scared that all of the hype around .NET this and E that is somehow going to make it either harder or slower to get to your files? Oh, excellent, excellent. And how many people are here because you looked at the schedule lineup and you figured that this would be the shortest talk and therefore you could get first in line at lunch? Okay. Pretty good, pretty good. Well, I actually hope that I can make people in all three categories happy, because there actually is a lot of incredibly cool technology that is coming in .NET Server just about the file server scenario. Also, in many ways, this is the anti-hype talk. This talk is all about the basics of our file server business and about what our customers use servers for. File servers are the core of what Microsoft can sell in the server market. And the reason for that is that file servers really are still the core of what customers need. If you think of all of the doctors and lawyers and insurance companies out there that have billions of dollars of intellectual property stored in word processing documents or spreadsheets, you'll just realize the magnitude of the importance of file servers and file server technology. And what this talk is all about is very simple, basic stuff like how we are making file servers more reliable, how we're improving the raw performance and the scalability of our file servers, the work we're doing with availability and recovery, with security and with privacy, and actually probably the most exciting of all, the rich user experience that we're going to start adding in Windows.NET Server. Really, Windows.NET Server combined with Windows XP on the client is probably the best file server end-to-end solution out there. In this talk, I want to focus on three main areas. First, I want to talk about the client experience and some of the incredible innovations that we're going to be making in the client scenario in .NET Server with Windows XP. Then I want to talk about the details of individual file servers. If you just have one file server in a small office, what are the advantages going to be if you have .NET Server? And then finally, I'm going to tell you how, as your enterprise grows, as your business grows, as you start having more and more file servers, they cooperate to provide an even better experience for the administrator. So let's start by talking about the client experience and one of the most exciting new features that's coming, and that's shadow copies. Now, if you were here in the previous talk, you probably heard quite a bit about shadow copies and the way it relates to backup applications and how it's going to make just the everyday problem of backing up a file server easier to manage. What I want to talk about here is another application of shadow copies and how it will make the end user's experience of a file server better. What we have, oh, no mouse, there we go. What we have when you are using a Windows XP client against a Windows.NET Server is a new capability that exploits shadow copies that allows somebody to view a previous version of a document stored on that server. Just by clicking on the View Previous Versions task, you can get a list of previous versions of a file that is maintained on the server. It's a lot easier just to walk through a scenario. for you to realize the importance of this feature. Use your imagination here, and let me paint this scenario for you. Imagine that I'm a program manager and that I have to work on a PowerPoint presentation. And this PowerPoint presentation is originally developed for an internal audience. It's got a lot of confidential material in it, and I want to deliver this talk to an outside audience. So I have to go in to my presentation. I have to remove all of the confidential plans about how we're going to take over the world. And then I go and I click Save As, but I click O. I clicked Save instead of Save As. Okay? I'll try to get out of this mess. Undo. You can't undo once you've saved. All right? I just obliterated about 2/3 of my slides. At this point, today, I would have two options. I could, one, give the IT department a call, have them find the most recent backup tape, pull out the backup tape, search for my file, restore the file to the file server. They'll call me back, see if it's the right file, and then after probably 5 hours and a charge back to my department of a couple of $100, I would be ready to go again. Or I could take that same 5 hours and reconstruct the slides that I just deleted. The better option, and the scenario that we want to enable in Windows.NET Server, is the View Previous Versions task that appears here because I am working on a .NET server. All I have to do is click View Previous Versions, and you see that the file server has been maintaining previous versions of this file on my behalf, and it's going to let me get back to them. If I click here and click View, I can verify that, yes, indeed, this is my complete presentation. So I breathe a sigh of relief, I highlight the version, click Revert. Yes, I really do want to bring this old copy back. And voila, I've just saved myself hours of work, hours of headache. All because I was saving my files on a Windows.NET file server. So let me show you all that you have to do on the server side of things to make this feature possible. What's happening on the server is we're taking advantage of the shadow copy technology that you've already heard about in the backup context. It's the ability of a server to maintain point-in-time copies, read-only copies, of volumes. The way you would administer this is you would just click on a volume and go to the volume properties. There's a new tab here called Shadow Copies. And you will see that my D volume, which is my data volume, has 3 shadow copies maintained. And all I have to do to enable shadow copies on a new volume, say I started creating shares off of my C volume, is just highlight the volume and click Enable. What this is doing on the back end is it is doing 3 things. The first thing is it's doing the basic configuration of the shadow copy infrastructure. As an administrator, the 2 things you have to worry about are how much disk space you want to reserve for maintaining shadow copies and which volume you want to use for that disk space. By default, if you just clicked that Enable button, you will take up to 10% of the current volume to store shadow copies. So you'll see here, if we went into Settings, that it's going to use up to 204 megabytes, this is a 2 gigabyte volume, on the C drive to store shadow copies. The other administrative aspect of this is how frequently do you want to create new shadow copies. By default, if you just click that Enable button, you get 2 a day every workday, 1 at 7 a.m., 1 at 12 p.m. The idea being that if you go in and just click Enable, the users of the file server will, in the event that something goes wrong, have a backup copy of what they were working on that was, at most, a couple of hours old. That's it. This is a set up and forget type of feature. Once I have made those total of 3 configuration choices, I don't have to worry about this feature again. Now, in terms of space management, you might be wondering, how much space does it take in order to maintain shadow copies of a data volume? If I have 10 gigabytes of data out there, do I have to wait as the shadow copy copies all 10 gigabytes to some backup location? And the answer is no. What we're doing on the server side is just keeping block level differences as changes are made. So creating a new shadow copy, say if I go back to my D volume and ask it to create a shadow copy, even on a fairly slow laptop, only takes 10 to 15 seconds. It could be much faster on a fast server with a fast disk. And all it is really doing is setting up some memory structures, creating a new file on disk, and then from that point on, keeping track of new changes as they happen. So really, the amount of space you need to maintain to preserve shadow copies is dependent not on how much data you have, but rather upon how frequently people are changing different files. So this feature should really be an incredible help both to administrators who will, with any luck, be restoring files from tape much less frequently. And it should also be just this amazing benefit to the end users who suddenly have the ability to get to old copies of files themselves and to get themselves out of all types of jams. Now, another great technology for the client side is client-side caching. Now, this is something that's been around for a couple of versions of Windows now. And the goal of client-side caching is to provide a seamless online and offline transition for the clients. If this laptop had been set up using Windows XP Professional Edition instead of Server Edition, I could show you all of the great things about client-side caching because it would have all of my documents, which I store on a server, which is using shadow copies. I love that feature. They would all be cached locally on my disk as well, so that as I disconnect my laptop and carry it over somewhere else, I can just seamlessly access the files that I have there. So that's the benefit to the client, the ability to just disconnect and connect to the network and have no real interruption in service. It has great benefits for the server as well because it reduces the server load. Even when I'm connected to the network, things can be set up so that I will be doing the work on the local cached copy of the files instead of hitting the server. So most people aren't aware that client-side caching is really useful in 2 big scenarios. The idea of redirecting something like a My Documents folder for the people who use laptops to get a cached copy that they can take offline, but also it's a wonderful feature if you're running any applications directly off the network, because you can set up client-side caching so that the application will run from the cached copy on the individual's laptop or desktop machine. Now, Windows XP is really the best client-side caching platform. There are several important scenarios that did not work or did not work well in Windows 2000 with client-side caching that have been addressed in Windows XP. Most notably, if you are set up to use EFS, the encrypting file system, then client-side caching will keep the cache on your laptop encrypted as well. So this really does address the stolen laptop scenario. If I'm redirecting my documents to a server, I have the encrypted file system set up, I carry my laptop on a plane but accidentally leave it in a lounge, the cached copy of all of those files will be encrypted. The other scenario that we addressed in Windows XP is support for DFS, the distributed file system. The Windows 2000 client cannot handle the distributed file system namespace and does not cache documents properly. This scenario has been fixed for the Windows XP client, and I will be talking in much more detail about the distributed file system later. So we've talked about what the end user experience is if you are using a Windows.NET server as your file server platform. Now let's talk a little bit more about what happens in the back room, on the server side. What's the performance like? How can I make sure that my server is available? How do I manage this thing? Several of the new availability features, if you were in the previous talk, you will have seen already. The fact that you can dynamically expand a volume without needing to reboot the server is an incredible help to administrators for continuing to provide service even as you need to do maintenance on the server. I'm going to skip the demo here just because in the previous talk Steve Olson did a demonstration of these tools. But if you want any more details on how these tools work, feel free to ask me afterwards. The other nice thing that Steve also spent a lot of time talking about is online backup. In Windows 2000 and in previous versions of Windows, there was an enormous problem of backing up files while they are in use. Backing up a PST file, for instance, whenever somebody had it open. Many applications take an exclusive handle on the file that they are working on, preventing the backup application from reading it. Now, in Windows NT 4 and in Windows 2000, to solve this problem, backup vendors had to write an open file agent, which was a kernel module that they would install that would allow them to bypass those checks. That scheme has so many problems. It's a reliability issue. The fact that you have to have something running in the kernel by a backup vendor just to get to your files could lead to blue screens, could lead to performance issues. Just a nightmare, just a nightmare. What we have added in Windows XP Client and what we have added in Windows.NET Server is the ability to create a shadow copy of a volume, which would be a read-only copy of the files on disk that the backup application could then mount, suck off the files that they need, and stick them on the backup media. No longer any need for a third-party open file agent. I can do my backups while other people are using their files, and I get a nice, clean, consistent copy. I'm going to skip the demo of the disk management tools because they were covered in the previous talk, but again, if you have any questions about them at the end, please ask me. Now, another big issue in terms of availability of file servers has to do with the drivers that you do have to load on your machines just due to the realities of the world that we live in. Antivirus. Viruses are an enormous problem, and in order for an antivirus product to make sure that they are scanning everything that changes, they need a piece of kernel mode code so that they can get triggered when files are opened and closed. In the Windows NT 4 time frame, these third-party add-ons were 12% of the blue screens that were reported to product support. What we have done to address this problem, since we don't want to, and there's no way to, remove antivirus products from our customers' machines, is we've instituted what we call plug fests. These are regular ISV workshops where the third-party developers come to Redmond. They work with our developers, they work with our testers to improve the quality of their drivers. We submit their drivers to our own internal I/O stress tests. We do interop testing to make sure that if you have an antivirus product and a third-party quota product installed, that they will work together. And the focus of these events is on robustness. And they have been paying off. The online crash analysis tool. If you've ever clicked that, your system has recovered from a serious error, do you want to report it to Microsoft? It comes into our online crash analysis center. And of the top 100 blue screens caused by ISVs, none of them are from file system filters anymore. Another thing that we've done to improve the driver quality is institute a logo program for antivirus software. So people like McAfee, Trend, and Symantec have given their software to us. When they are ready to ship it, we will submit it to a standardized series of tests and make sure that it is of a sufficiently high quality to get a seal on it. So by looking for this logo, you can make sure that these are the vendors who have been coming to these ISV workshops and who have focused on robustness. Your file server will thank you for it. Another huge problem of availability, or rather lack of availability, in the Windows NT 4 timeframe is check disk. Now, if you're using NTFS, the journaling features of NTFS mean that less than 1% of the times that your machine shuts down unexpectedly do you even need check disk. But in NT4, if you did need a check disk, and if your volume was big and more importantly had lots of files, then you could be waiting for a long, long time. We've addressed the check disk algorithms, and in Windows 2000 we were able to improve check disk times by a factor of 6. We've continued to improve check disk times, and in Windows XP and in Windows.NET Server, check disk is several orders of magnitude, at least 2 orders of magnitude faster than it would be on Windows NT 4. File server manageability is another key thing and a key reason why Windows.NET Server is going to be an improvement in the file server space. As you saw in the previous talk, DiskPart is now available to script disk partitioning operations. You can extend volumes through a script, you can delete partitions, you can configure hundreds of file servers to have the exact disk configuration you want just by writing a script and sending it out to those machines. Similarly, there's a little-known tool called FSUtil that gives you scriptable ways to control the USN journal, Object ID support, several other advanced NTFS features available from the command line and available through scripts. Since Windows 2000, we have provided native capabilities to institute per user and per volume quotas. This is an essential tool to make sure that you don't unexpectedly run out of disk space on a file server. And finally, we've tried to improve the defragmentation tools. The defrag engine has been reworked. It's now significantly faster, and it also includes functionality that did not exist in previous editions of Windows. You can do, for instance, online defragmentation of the NTFS master file table. Scalability. NTFS can handle enormous volumes. It can handle enormous numbers of files. These are the numbers that existed when we shipped Windows 2000, and they've just been getting higher as we've been developing Windows XP and Windows.NET Server. We have tested NTFS on a 17 terabyte volume. We have tested it with a 16 terabyte uncompressed file and a 69 terabyte compressed file. You can handle millions of files, millions of directories, incredible numbers of allocation units, incredibly fragmented files, and the system just works. So one half of scalability is going to be, what are the limits of the file system? Now, the other half of scalability is, how fast is the file system? And we're really thrilled with the performance numbers that are coming in with Windows.NET Server, in particular when it's using a Windows XP client. When you're taking a look at NetBench results and just a single processor server, then there's a 50% improvement in throughput if you're using Windows .NET Server for the file server and Windows XP for the clients. The numbers are even more impressive if you're taking a look at multiprocessor scaling. We have a 110% improvement in the throughput on an 8-way machine when you're using Windows .NET Server on the server side and when you're using Windows XP as the client. We've made important improvements in the lock contention and in the file server protocol to make these scalability improvements possible. So your file server can get big in terms of the number of files that you have, the number of directories you have, and it can also handle a much larger client load than it could in the past. Now, let's talk about the federated file server scenario. This is what happens as your business starts growing, as you start having more and more file servers, and as you want to continue to provide a nice end-user experience. There are several things that you would want to do as you start adding more and more file servers to your business. One thing you might want to do is unify the namespace of several different servers that you have in your company. We're a software development company, so let's talk about some of the issues that we face as a software development company. We would have servers that maintain products that we build that are developer tools. It's done by one division. They have one set of servers where they put all of their applications. And yet another division has another set of servers where they've built all of their end-user applications, and that's where the applications go. But as a lowly program manager, I don't want to know that to install a developer tool, I have to talk to the developer division servers. To install Office, I have to talk to Office's servers. I just want to go to one location, products, and get those different applications through a single namespace. The distributed file system will work in this scenario. In fact, let's just get rid of the slides for a second, and let's show you how this can work. The distributed file system has been around since Windows NT 4.0 Enterprise Edition, or it was the option pack, one of those add-ons that we had for NT 4.0. But there are still several people who don't realize all of the uses that DFS can be applied to. The way you get started using DFS is you set up a DFS root. I want to select a standalone root since my laptop is not a domain controller. My server name is Dewey Laptop 5 server. Let's just create a root called DFS. What a DFS root is it's the start of the namespace. And now I can start making several different servers available through this one location just by adding a link. So I've selected the root, and all I want to do is create a new link. Let's see who I can connect to. Link name will be Office Computer. Let's see if I can connect to my computer back in the office. And path to the target, Dewey for public. Now, whenever I connect to this one server that's serving as the DFS root, and I connect out to my office computer, well, it will just seamlessly redirect me to that other server. There's no need for me as the client to realize however many dozens of servers are coalesced into a single namespace. So as your business starts adding servers, or as an administrator, as you just want to have kind of a service layer so you can swap servers in and out and provide a seamless end user experience, you just manipulate the links. Now another scenario that you can address with DFS, aside from just this namespace abstraction and the ability to add servers in and out, is load balancing. You can add secondary servers or new servers to service the same DFS link. So now this office computer link is being serviced by both Dewey 4, my machine back in my office here in Redmond, and by this local laptop right here. And what will happen as clients start connecting to this machine, to this DFS route, is it will start load balancing the connections across the two machines. In a product server scenario, this can be incredibly valuable. As you start unrolling a new product, or as you for any company that publishes anything on a network share, if you expect a high amount of demand, by setting up replicas this way, you can distribute the load seamlessly among multiple servers. Now, to keep this in sync, these two different copies, I could either manually copy files back and forth, or I can use the file replication service. The file replication service was added in Windows 2000 to work with DFS, to work with the Active Directory, and to work with several other user-defined configurations to keep different file servers in sync. So if I was using DFS in a My Documents scenario, and it was spread across multiple servers, as I make changes to one file server, DFS will make sure that the changes are replicated to the other. And wow, it works. From a client's perspective, it's completely transparent. I'm talking to, if you look up here, this local computer. I'm talking to my DFS share. This junction point is actually taking me to my computer back in my office. I had no idea I was actually on the corporate network here. That was a surprise. Let's talk about some of the new things that have been added to DFS in Windows.NET Server. One new thing is the ability to support multiple DFS routes per server. This is a key feature for cluster scenarios. This means you can set up, if you're using Enterprise Server, you could set up a 4-node cluster. You could have, by default, each node in the cluster host its own DFS route. And if ever there is a failure, that route can easily fail over to another node in that cluster, and that node can service both routes at the same time. This is also just another way to make things easier for you, the administrator, in terms of how you set up your namespace. If you want just one server to consolidate DFS routes from what used to be multiple servers, you can do that in Windows.NET Server. Another thing that is new in Windows.NET Server is the delegation of administration. If you are an IT director for a global company and you're trying to unify the namespace of all of your different subsidiaries into one DFS route, you can do that. You can have one global route, say at your corporate headquarters, and then you can have a DFS junction that takes you off to the Singapore or to the London branch, and you can delegate the administration of that particular piece of the DFS namespace to the administrators at your Singapore or your London branch. In the past, to administer any part of the namespace, you had to be an overall domain administrator. So that person who works out in London would have to be an administrator at your corporate office as well. Now you can have true delegation of administration over parts of that namespace. Another thing that is amazingly useful in DFS for Windows.NET Server is what we call dynamic site awareness. Now, it used to be that if you had set up replicas of DFS junction points and a client was trying to connect to a replica, it would first try to make an intelligent choice. Actually, let me be a little more detailed in the scenario. I'm once again working in a global company. I'm working here in Redmond, and there are replicas of a product server, both 2 replicas here in Redmond, 1 replica over in Singapore. My client machine, when I try to connect to the product server, is smart enough to realize that, okay, I'm in Redmond, I will try to connect to one of the 2 replicas that are set up here in Redmond. Now, if both of those are down, it will then pick some other replica at random, and it won't make any distinction between, say, an office or a replica that is down in Silicon Valley and a replica that's over in Singapore. It just picks one at random. For Windows.NET Server, we do have the notion of cost built in to how expensive it is to access replicas that are on different sites. So the client will know and the servers will know that it is much less expensive for me to reach the replicas that are in Silicon Valley than it is to reach the replicas in Singapore. So when those Redmond-based replicas go down, I'm going to be redirected to the closest site, or more specifically, the least expensive site. Now, this allows very nice failover configurations that you can set up. You can set up one DFS replica on a local site. You can set up another replica on a very low-cost site. Everybody who's here in Redmond will be, by default, talking to that local replica. The file replication service can be set up to replicate all changes to essentially your warm standby in the different site. And if the replica in the local site ever goes down, there will be a seamless transition to the replica in the failover site. So it's a very nice way to set up geographically distributed failover. And the final set of improvements that we've made in the distributed file system is we've worked on just raw scalability improvements. We've reduced the amount of time it takes to start up or to configure DFS. This is particularly noticeable if you start having lots of DFS links. We've worked on batching up the requests for synchronization, and we've decreased the memory footprint for the DFS server. Now, the file replication service is the technology in .NET Server that makes all of that automatic synchronization of DFS routes possible. The major improvements in the file replication service for .NET Server is deployment of FRS, developing better tools in the resource kit, and working on efficiency and robustness. There are no major bell and whistle features for FRS. It's strictly about making sure that this is a feature that you can use, manage, and depend upon in your environment. So to summarize, and as promised, we're finishing nice and early for plenty of time for questions and lunch. To summarize, we're going to continue to improve the client experience. The client experience is really one of the key, it's the way end users know what file server they're talking to, and it provides tangible server benefits. You can make the clients in your network happy by providing previous versions to them, and it lessens the cost for your server administrators. They're not restoring from tape as often. Client-side caching makes the offline scenario better for the clients and reduces the load on the server. The improvements that we're doing in availability, manageability, and scalability mean that Windows remains a great platform for a single file server or a departmental file server. And the work and the improvements in the distributed file system and in the file replication service mean that those departmental file servers can easily scale up, and you can run your enterprise on Windows file servers. So with that, let's take some questions. Yes, sir?
With regard to the dynamic site awareness, is that accomplished through server resource records and DNS, or is the cost built into the links that you create?
I believe that the cost is built in. Oh, I'm sorry. To repeat the question was, where is, or how does the dynamic site awareness work? Where is that configuration information stored? Is it stored in DNS? I believe that the information is stored in the Active Directory. You set up the cost for working with multiple Active Directory sites. And then DFS gets the configuration information out of the AD.
It's usually, that's right, it's usually existing site costing already set up for the AD. No extra work required to do the data.
Yes, sir.
I've got a question on FRS compression. Is that, do you know what the level of compression is when these replicas, how that compression works?
I have. So the question was, FRS compression. What is the level of compression? How does it work? I actually have absolutely no idea. But somebody in the back has an idea.
It's using normal levels of compression algorithm.
Yeah, we've done some testing. A lot of the stuff we've found is that for FRS, it doesn't compress files. So you drop a whole
Which
bunch of files
version
in.
of FRS are you using?
That would be 2000.
Okay. Compression version is service pack 2.
Okay, so to summarize for the people who will be listening on my microphone, that conversation, FRS in Windows 2000 did not, in the RTM version of Windows 2000, did not do compression. Compression was added in Windows 2000 Service Pack 2, and it's using fairly standard file compression algorithms. Yes?
Real quick, what level of compression is that? And secondly, have you guys looked at possibly scheduling, allowing us some type of scheduling between sites for FRS replication?
The question was, what level of compression, and can you schedule replication between sites? As I still don't know what level of compression, aside from that it was, is it using the regular NTFS compression algorithms, David? It's using if you choose to compress a file in NTFS, we're using the exact same algorithm to compress for FRS. And in terms of scheduling FRS, I don't know if that, yes, that is configurable by the administrator.
Yes, on an hour basis. You can do 7 by 24 array. You can schedule on or off any hour when you
So FRS is apparently schedulable by the hour. Yes, sir, in the back.
How many replicas can you have for a link?
The question was, how many replicas can you have for a link? David, are there limits?
For branch office, how many things I can fulfill?
Okay, this will be the first question, so I'll speak up again. So, it varies in your organization. We have some customers who have 5,000 on particularly. If you have a lot, you can break down the other columns and really that many, you have a few people with thousands of replicas. It can be done using database columns.
So the answer is you can go up to 5,000. We have people who have done up to thousands of replicas on a link. Does anybody have any questions about shadow copies? Please, ask me something I know.
What version of XP Professional do I need for shadow copies?
Excellent question. What version of Windows XP do you need for shadow copies? You will need Windows XP Service Pack 1 is what we will support. There are some changes in the client-server protocol that will be in the Service Pack. There will be some new client code in the Service Pack. If you are interested in trying shadow copies now, and you have a copy of Server Beta 3, The client code is in an MSI package on that server CD. There is a client's subdirectory under your Windows System 32. There's a TW client in addition to the terminal server client, in addition to the fax client. There is a client for accessing shadow copies, and you can install it on any Windows XP machine since there's no Service Pack 1 yet. Yes, sir?
On the shadow copy configuration, you mentioned you could store those shadow copies on another volume somewhere. I didn't see that configuration option in your demo. Is that in there now, or is that a later feature?
So the question is, I'd mentioned that you can store the shadow copy difference file on another volume. Was that in the UI? Is that a feature that's in there now, or is it something that will be added later? The feature is in there now, and it's in the UI now, although it's not on that main page. You have to go first to the settings page. One limitation is you can't change the volume once shadow copies are enabled. So if you really wanted to set it up to use a different volume, you need to tweak your settings first and then enable the feature. And the reason why you would... One more restriction is the volume has to be local, so you can't store it on another volume on another computer. And storing the differences on another volume is actually the recommended practice for any server that has a high I/O load. It improves the seek performance as you're trying to maintain these differences. Yes, sir?
Okay, so you're saying that I couldn't set up an arrangement where my shadow copies are sent to a NAS device?
The question was, can you set up an arrangement where the shadow copies are sent to a NAS device? The answer is no. It has to be it has to look like locally attached storage to the server. If anything where you are connecting over a file-based protocol to another server, you cannot do.
Will that support be added in the future? You know?
Potentially. The question was, will the support be added in the future? Potentially. Not in the near future, I can tell you that. Yes, sir?
Shadow copy, can you set that to roll over by days rather than by percentage of disk space? So I want to keep previous versions for 25 days.
So the question was, can you age out the shadow copies based upon how old they are rather than upon how much disk space they are using? For this first version, it is strictly a disk-based reclamation. So as you run out of space, we start reclaiming the oldest shadow copy. We will look on adding an age-based way of reclaiming shadow copies in a future version. Other questions? Yes, sir?
If you have your shadow copy on a volume that is being managed by the remote storage, how does that treat it? How does the remote storage treat it?
What a great question. The question was, if I have shadow copies on a volume that is using remote storage, so the hierarchical storage management, how does that work? The answer is, I love this. It just works. It's great. What will happen is, if you are, I'm going to have to try to describe a fairly complex scenario because all the different interop matrices and points can get fairly involved, but we went through all of these and it just works. Hierarchical storage management is the capability of Windows 2000 and Windows .NET Server to move the data from a file onto some sort of secondary storage, a tape, or actually I should have mentioned this in my talk, in .NET Server magneto-optical disks, and then it can be transparently recalled as people access that data. So what will happen then if there is a file that is off on tape at 7 o'clock in the morning, and that's when I create a shadow copy, and then somebody tries to get at that 7 o'clock shadow copy. The volume, that 7 o'clock shadow copy volume, is read-only. Is remote storage going to try to recall to a read-only volume and fail, therefore blocking me from accessing my file? The answer is no. Remote storage will take advantage of its capability to read the data directly into the user's supplied buffer. So we will allow the reads to complete without having to stick the data on that read-only shadow copy. So I can go back to my 7 o'clock shadow copy and access an old migrated file. It will still do the recall. I will still get the data. And it will work even if I've recalled the file and changed it at a later point in time. Other questions? Yes, sir.
So DFS again.
Oh, no. Please be a simple one.
I suppose it is. As I recall it, DFS doesn't, enumerate the access control list on share level. So if I build a DFS with all my shares in it, all my clients will see all the links, and only when they access one, then they will give access denied. Is that the same now?
Yes, that is correct. So the question was, does DFS take a look at the access control lists and essentially hide any shares that you don't have access to? So if you're trying to build a company-wide DFS route and there are, say, one DFS link for each user to store their home directory, will they see the whole list or will they just see the ones they have access to? For Windows.NET Server, you will still see the entire list, and only when you try to access something will you get the access denied message. Good, that's one I knew.
It could be like that forever.
We have definitely thought about changing it, and it is something that that we looked at for .NET Server and didn't have the time to implement. So perhaps in the future. Yes, sir.
Does FRS support both asynchronous and synchronous replication?
I believe that FRS, and David will correct me if I'm wrong, that FRS is asynchronous replication only. The question was FRS, does it support both asynchronous and synchronous? Other questions? All right, enjoy. Oh, okay, one last one, right under the bell.
On some of the performance charts,
yes, sir.
About an XP Plus client, is that just service pack testing?
So the question was, on some of the performance charts, it talked about XP Plus clients, and was that just Service Pack Windows XP? I believe the answer is yes. So it is code that you will be able to get. All right, please fill out the speaker evaluation forms, drop them in the box. Enjoy your lunch. We got you out of here before 12 o'clock. You were a great audience. Thank you very much.